Hello student, welcome back to lecture series on statistic. Guys, we have completed entire statistic unit in our channel. Okay, so for my today's purpose of my today's video, guys, I am trying to explain to you all the formulas and important concept within our entire statistic chapter that we learn. Okay, yes, see that in most of the concept like a frequency distribution or like a standard deviation or any other formula for same topic, guys, I explain plenty of the formulas here. Okay, so they have their connections also. You can use anything, you will get the equivalent answer. Okay, not an issue. But still most of you all are feeling that no sir, it is really so many formulas, how can we remember? So I found the comment from student that they want the shorter formulas or a specific formula as per the topic, so that they can remember it for their exam. Okay, yes, so today's lecture, it is completely based on the formulas, okay, and short concept that we needed for our statistic question paper. Okay, now see that, guys, the formula which I am giving here, you completely use these formulas. Okay, because all formulas are associated each other, so you can use this formula for solving your examples in your question paper. Okay, yes, so let's get start. Okay, without further ado, let's get dive into our today's lecture. I'm going to explain to you all formula with their detailed understanding. Okay, yes, so here in my today's lecture, I took some all formulas from the statistic unit on separate page. Okay, so if you want the list of formulas, I'll share that PDF link in my description box. Okay, yes, so here in our static we started with mean, mode, median. Okay, yes, so mean, we know that whenever we have ungrouped data, so we add all the numbers divided by n. Okay, so whenever we have entrance of a frequency, okay, so that means whenever we have frequency given with a class mark or a regular observation, so we consider their mean as summation of fi xi divided by capital N. Okay, and capital N throughout this statistic, okay, throughout the statistic chapter, capital N we designated for summation of fi. Okay, yes. Now later on we learn method of a step deviation. Okay, step deviation means whenever we have higher number of calculation or to reduce the calculation, we define the method of a step deviation. So for the particular xi, higher xi, we consider ui. Okay, yes, so we define ui for our xi table. So see that here we have some random terminology. xi means the table which we have given in our data set. A means middlemost value over there. Okay, yes, h is the step size, means length of the interval. Okay, and we define it as the x bar is equal to a plus h into u bar. Okay, and u bar means is the arithmetic mean for u. Okay, that means summation of ui divided by summation of fi. Okay, let's go for the next, median. Median means middlemost term. Okay, when n is odd, we consider n plus 1 by 2 is the middlemost. When n is even, then we consider n by 2 plus n by 2 plus 1 the term by 2. Okay, this one is for even term. Okay, yes, whenever you have ungrouped data, okay, so you can use these to form for a formula for finding median. Okay, so whenever we have group data, means we have frequency given, okay, cumulative frequency given, so that we have to consider this formula. L means lower limit, h means step size, n by 2 means n is a capital summation of fi. Okay, by 2 minus c means we have cumulative frequency. Okay, that can be defined preceding frequency of fi. Okay, yes, so this one is a capital F over here. Okay, yes. This is the formula, guys. Okay, then let's go for the next mode means mostly repeated value. Okay, mode means mostly repeated value in our data set. Okay, so if you have frequency distribution given, so you take this formula L plus h into f1 minus f0 upon 2f1 minus f2 minus f0. Okay, this one is the standard formula. Okay, for mean deviation, whenever we have grouped data, ungrouped data, okay, whenever we have ungrouped data, we consider I which is equal to 1 to n, summation I which is equal to 1 to n, modulus of xi minus x bar divided by n. Okay, this one is for mean deviation whenever we have ungrouped data. And whenever we have grouped data, we introduce fi over here. Okay, fi here and small n to the capital N, that means summation of fi. This fi and this summation of fi we have to add here. Okay, for mean deviation. This one is for ungrouped data, this one is for the group data, guys. Okay, yes. Next formula for standard deviation. Okay, standard deviation means square root of variance. Standard deviation means square root of variance. Okay, so you see that, guys, in our entire statistic chapter we use everywhere standard deviation. Okay, standard deviation with respect to x, standard deviation with respect to y. Okay, so now see that I written over here standard deviation with respect to x as a square root of summation of xi square divided by n minus summation of xi by n bracket square. Okay, so instead of that, if you have yi as a table given, so you replace only summation of yi square divided by n minus summation of yi by n bracket square. Okay, this one is for yi. Yes, so when we have frequency distribution given, so introduce fi under summation, introduce fi under summation, capital small n replaced by capital N. Okay, that I written here, summation of fi xi bracket square upon summation of fi, capital N can be written as summation of fi. Okay, minus summation of fi xi divided by summation of fi bracket square. Okay, yes, and for step deviation, just to reduce calculation, we consider this one. Okay, u which is equal to x minus a. Okay, sigma of u. Okay, with respect to u we are taking standard deviation. Okay, this formula both are equivalent, but instead of x we have u, so replace u only here. Okay, so u over here, fi it is remains. F means summation of fi, guys. Okay, I did not mention fi, but summation of f means summation of fi. Okay, yes, so remember everywhere from now onward, summation of f means summation of fi. Okay, into u bracket square divided by summation of f, and u means ui. Okay, so here from you get the u is equal to x minus a. X means excitable, a means middlemost value. Okay, yes, and whenever we have, okay, this one is standard deviation whenever we have a regular data set given, but whenever we have interval type of data set like a 10 to 20, 20 to 30, in such a case we use u is equal to x minus a divided by h. Okay, so h is the interval size. Okay, like a 10 to 20 means h is equal to 10, 20 to 30 means h is equal to 10. Okay, that means step size or width of the interval. A means middlemost value, x means excitable, sigma of u is equal to h means step size. Okay, under square root summation of f into u square divided by summation of f minus summation of f u upon summation of f bracket square. Okay, see that, guys, this one is the important formula. Okay, I hope you all have understood this one, not the difficult. It is same formula, guys, for standard deviation used everywhere. If a standard deviation with respect to x and standard deviation with respect to u, if just a variable change, it doesn't matter, you can remember the formula. Okay, it's way easier to remember. Yes, so let's go for next formula. Okay, standard deviation I explained here. Then coefficient of variation. Okay, so you will get the question, find out the coefficient of variation or coefficient of variability. Okay, yes, so we coefficient of variation we write standard deviation. This sigma means standard deviation upon arithmetic mean multiplied by 100. Okay, so here we have a coefficient of variation or variability. Okay, so the lesser coefficient of variation or variability means more consistent value. Okay, so you will get the question in your question paper, find out the consistency. Okay, for data sets. So wherever you get the lesser coefficient of variation, you will get the more consistent. Okay, let's go for the next point. We learn momentous. Okay, for momentous we learn central momentous and raw momentous. Okay, central momentous we denoted mu and raw momentous we denoted mu dash. Okay, so if you want, you can refer this formula, because this in my regular lecture I expand this formula. Okay, so if you want short form to remember this one, you can take this form. Okay, so summation of fi xi minus x bar bracket to the power r summation of fi denominator. Okay, this one is for central momentous. Raw momentous, that means if you want mu naught, replace r by 0. If you want mu 1, replace r by 1. Okay, so you will get the required mu naught, mu 1, mu 2, mu 3 and so on. Okay, again raw momentous, that means whenever we have dash, mu r dash, okay, we consider raw momentous. Okay, yes, so for raw momentous we use summation of fi xi minus a to the power r divided by summation of fi. Okay, what is this a? This is the middlemost value. Okay, in our given data set. X bar means arithmetic mean over here. Okay, yes, so when we have class interval like a 10 to 20, 20 to 30, so we used to find the raw momentous using the following formula, like mu r dash which is equal to h to the power r summation of f u to the power upon summation of f. Okay, and that u defined as x minus a divided by h. A means middlemost value, h is a step length. Okay, that means interval length. See, guys, that mu and that u both are the different, don't get confused. this is a mu and this is a u we define this one, mu we define this one. Okay, yes, don't get confused. Say I hope you all understood raw and central momentous. Let's go for the relationship between mu r and mu r dash. Okay, that means the relationship between central momentous and raw momentous. Okay, so we always take mu naught 1, mu 1 0. Okay, and mu 2 is a variance. Okay, mu 2 we know that mu 2 we call as the variance. Okay, so this mu 2 is a variance. So mu 2 can be found by mu 2 dash minus mu 1 dash bracket square, mu 3 written over here, mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash cube, and mu 4 can be found by mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash mu 1 dash square minus 3 mu 1 dash to the power 4. Okay, yes, this is the relation between central momentous and raw momentous. All mu naught, mu 2, mu 3, mu 4, mu 1 all are the value for central momentous and their dash value for raw momentous. Okay, so if you have given raw momentous, you can easily find out the central momentous. Okay, and make sure that mu 2 can be written as variances. Okay, it will be helpful for finding the standard deviation, and standard deviation is the square root of variance. Okay, yes, next after that skewness, we go for the skewness. See that here I written this formula skewness. Skewness can be found by 3 times square under bracket mean minus median upon standard deviation, and coefficient of skewness can be found by mu 3 square upon mu 2 cube. Okay, and denoted as beta 1. Okay, and gamma 1 which is equal to plus square root of beta 1. Okay, yes, mu 3 and mu 2, these are the central deviation. You can these are the central mode. Okay, so sorry, these are the central momentous that you can find using our momentous point. Okay, yes, then thereafter you will get the question, find the coefficient of kurtosis. Okay, find the coefficient of now this one is the coefficient of skewness. Next, coefficient of kurtosis. Coefficient of kurtosis denoted as beta 2 and written as mu 4 upon mu 2 square, and gamma 2 can be written as beta 2 minus 3. Okay, yes, note it down these formulas, guys. Okay, so we go for the types of kurtosis. Okay, types of kurtosis we learn majorly 3 types. Okay, majorly 3 types of the kurtosis. First, mesokurtosis, also called as a normal curve. Okay, so the curve which neither have peak point nor have flatness. Okay, yes, the curve which is neither peak nor flat, or beta 2 can be written as a 3. Okay, or gamma 2 which is equal to 0. In such a condition we call it as a mesokurtosis. Then platokurtosis, if the curve is a flat, beta 2 smaller than 3, gamma 2 smaller than 0. Okay, in such a case we consider it's platokurtosis. Okay, and third part, leptokurtosis. So leptokurtosis means the curve which having only peak point. Okay, the curve which having only peak point. If beta 2 bigger than 3, gamma 2 bigger than 0, then we consider leptokurtosis. Okay, yes, next we go for the next point that we learn, curve fitting. Okay, curve fitting method of a least square. Okay, method of a least square. This one is very much important, guys. I found everywhere in every question paper this question. Okay, curve fitting or method of least square. So see that whenever we have curved straight line y which is equal to x plus b, we consider the equation of a normal, summation of y which is equal to a times summation of x plus a and b, and summation of xy which is equal to a times summation of x square plus b times summation of x. Okay, and a parabola, when we have parabola like y which is equal to x square plus bx plus c. Okay, then we consider summation of y. Okay, summation of y as a c. This is a c. Okay, this is the c n my plus b times summation of x plus a times summation of x square. Summation of xy can be written as c times summation of x plus b times summation of x square plus a times summation of x cube. Summation of x square y can be written as c times summation of x square plus b times summation of x cube plus a times summation of x raised to 4. Okay, these are the value for parabola, equation of a normal. Okay, yes, let's go for the next. After curve fitting we learn correlation. Okay, correlation can be denoted as r of xy. Okay, so mostly we use one standard method. It is a Carl Pearson coefficient of a correlation. Okay, that one we use, and which written as r of xy is equal to covariance of xy upon sigma x sigma y. Okay, and sigma x means standard deviation with respect to x. Okay, so if you want to see sigma x, so you can take it from here. Sigma x means summation of xi square upon n minus summation of xi by n bracket square. Okay, and sigma of y means summation of yi bracket square upon n minus summation of yi by n bracket square. If the frequency table there, you have to use this standard deviation for xi yi. Okay, yes, this one is the value for sigma x sigma y. Okay, that is the standard deviation. Now next target to find out the covariance of xy. So covariance of xy can be written as covariance of xy is equal to summation of xi yi divided by n minus summation of xi by n into summation of yi by n. There are so many formulas, guys. You have to refer this only this formula. Okay, and whenever we have frequency given, okay, then covariance introduce fi here under summation, introduce fi here under summation, introduce fi here under summation, and instead of small n use capital N to the denominator, and capital N is the summation of fi. Okay, yes. So let's go for the next. When frequency given, okay, so see that I explained in my previous there's a covariance of xy, your summation of fi xi yi upon summation of fi minus some under bracket summation of fi xi upon summation of fi and summation of fi yi upon summation of fi. Okay, sorry, let me take this one again. Yes, see that here. See, this one is summation of fi, guys. Okay, might be you if you get confused. This one is a summation of fi. Okay, so this whenever we have frequency given, use this one. Okay, so whenever we have to go for some simplified calculation, okay, so use this method of a step deviation. Okay, so step deviation, what we consider, u and v consider over here. Okay, for step deviation. Yes, so see that here it is a step deviation. Note it down these points. Okay, r of uv, okay, it will remain same. Okay, correlation r of uv, it will remain same. It is the covariance of uv upon standard deviation of x, standard deviation of y. Okay, so that u can be found by xi minus a divided by n, and v can be found by yi minus b divided by k. Okay, let me introduce the variables. That xi means a table of xi in our given data set. A means middlemost value. N means how many times xi occur. Okay, in xi how many times values are there, so we consider n. Okay, similarly we consider vi. Okay, vi can be written as yi minus b upon k. So what is the b? B is the middlemost term in yi. K is number of term which present in yi. Okay, this is a k. So covariance can be found by similar like these values. Okay, so xy replaced by uv only. Okay, so covariance of uv, summation of ui vi minus summation of ui by n into summation of vi by n. Okay, that one is also, this one is also second formula. You can refer it for your preparation. That one is easier also. You can remember summation of ui vi minus n times u bar v bar upon under square root under bracket summation of u square minus n times u bar square under next bracket summation of u square minus n times u bar square. Okay, then next covariance of uv whenever frequency distribution given. Okay, so use summation of fi ui vi upon summation of fi minus summation of fi ui upon summation of fi and summation of fi vi upon summation of fi. We are seeing this formula, guys, from beginning of our statistic chapter. It's not that difficult. Okay, so after method of step deviation, we go for the regression. Okay, you can see here I mention all these results for regression. It is very important, guys. Nothing we have difficult, just need to remember 1 2 3 4 result. Okay, so if you want b of xy, b of yx, put this value, you will get the r square. Okay, yes. So regression, under regression we learn equation of a line of a regression. Okay, if equation of a line on regression of regression y on x is there, then we write y minus y bar, b of yx, x minus x bar. Okay, if a equation of a line of a regression x on y, y minus y, equation of a line of regression x on y, we write x minus x bar, in which is equal to b of xy into y minus y bar. Okay, yes. Then next regression coefficient. Okay, regression coefficient y on x, we write b of yx r of xy into sigma y by sigma x. Okay, and regression coefficient of x on y, we write b of xy r into sigma x by sigma y. Okay, yes. So whenever we multiply b of yx into xy, we get the r square. Okay, so see, guys, all these formulas are much important. Okay, I hope you all have understood these short formulas. Note it down, guys, revise it every day for your statistic paper. You will get the all question based on these formulas only. Okay, so you don't have to prepare any other formulas. Just take my today's formula, prepare it, recite it, solve the more example. You will get the out of marks in your END-SEM exam. So that's it, guys, here. Okay, I hope you all have understood everything here in my today's lecture, and we don't have anything difficult. It's one of the easier concept from statistics. I tried to simplify the concept, made it more simpler, just to understanding you all guys. Okay, I hope you all have understood my today's lecture. So even after, if you have any confusion regarding any doubt, difficulty regarding any short term, let me know in my comment section guys. I will come up with the similar videos. So that's it here for my today's lecture guys. So thank you everyone, thank you for my today's lecture.